So, good morning, good afternoon, good evening, people all around the world. Welcome to the webinar on data analytics in the GenAI era. So thank you all for joining this session from wherever you are in your comfort zone. So, before we start with the session, I will just give a quick intro of myself. My name is Mahalingam. I am a pre-sales manager and the center head for Kochi at InApp Information Technologies. Been with InApp for close to a couple of years now, coming from an academic background, and quite interested in how solutions are built for different problems which we see around us. So I'm not spending too much time on introducing myself. We will jump into the agenda straight away. So the title of the webinar was Data Analytics in the GenAI Era. So this is a really interesting topic. One reason being, GenAI is something which we see around us a lot today. So anyone who is in touch with the technology front has heard this term at least once a day for the last couple of years now. So for this particular webinar, I will start off with a quick intro of what this concept is all about. Then, like any other technical concept, we will start from the fundamentals, start with the data analytics fundamentals, then a primer on generative AI, then see how both these intersect at some point. And once we understand how these intersect, how these build across the verticals, we will see what are the challenges and opportunities, what are the best practices and implementation opportunities for these particular concepts. And then we look at a few case studies and come to a conclusion. So let's dive into the topic straight away. We are starting off with an introduction of what this concept is all about. Now, what is this generative AI? What is this data analytics? Why are they important? How are they interdependent? So these are certain keywords which many of us are aware of, but in depth, what do each of these mean? So start off with data analytics. So if you look at a technical definition per se, we can say it is the process of examining, transforming, and modeling data to discover useful information. And that is a lot of technical jargon put into a single line. But if you use really simple terms, it is all about analyzing raw data to get insights. And why do we need insights? Insights which will help us make informed decisions. So in even simpler terms, if we have data with us, make sense of what the data is all about and use it to make your decisions. And that's basically what data analytics is all about. So we may have 100 definitions out there, but at the end of the day, this is what it is meant for. And the other part of our discussion, which is generative AI, as I mentioned in the beginning, it's a really popular term today. And why it is popular is because this term has been paired a lot with artificial intelligence. So we are saying that AI and Gen AI, these two terms have been running around a lot lately. And they have gained importance because they have been used a lot for generating content like images or music or text. To put in really simple terms, let's start with the ChatGPT, where the concept of generative AI started gaining traction really quickly. And now we have an array of implementations for different types of operations. So we will see these in a bit more detail as we come on. And the peculiarity of these two terms have been consistently increasing in interest over time. And if you look at the graph below, this is Google search trends over the past 5 years. You can see that data analytics, which is the blue graph we see over there, was kind of flat for some time and then it suddenly shot up. So if you look at that note, that is when Google revised their analytics framework and web capture framework. And beyond that, again, data analytics has been a consistent term. And if you look at generative AI, it used to be non-existent for a long time, and suddenly it started peaking in interest across the world. And one reason is, as I mentioned just before, implementations like ChatGPT made people aware of this concept, and it started gaining importance. So these two terms have been around for a long time. Even though GenAI has already been here for a couple of years, that is actually a long time in terms of computing. So we will say that it has been around for a long time. But these two have been really important terms for us. So let's look at this aspect. So we just define these two terms, data analytics and generative AI. So data analytics is making sense of data, generative AI is generating something new. And today, the simple logic we all have is data is the new oil. So that is the most valuable asset for us today. Whether it's an organization or even a person, data is the most valuable asset nowadays. And these two terms together, these two concepts together, are really crucial in driving innovation, because today's innovations are data driven. When you are doing something on your mobile, when you're doing something on your laptop, when you're availing some service, data is being collected. Whenever you say, I agree to a particular consent request, inside there will be norms which say that we are collecting these data for our requirements to make your service more personalized, more suitable, more appropriate. And these kind of innovative thoughts are mostly data driven. And these data also help us solve complex problems, because there are many concepts or problems that are previously unknown to us. Why does this occur? And many of these are solvable by data. And if you have data, sometimes you can unlock new opportunities. You can do something much beyond what you were initially thinking. So these two terms. So data analytics, Gen AI. So how do they help each other? Data analytics improves the performance of Gen AI models. So generative AI is an AI model. So they work, there's some algorithms, they do some particular process. In the process, we can collect data. And that data can be used to improve performance of these Gen AI models. And how does Gen AI help data analytics? Generative AI, as we know, is commonly used for generating something. It could be generating data, it could be generating insights, something is being generated, and that will in turn help data analytics. So now let's look at some fundamental concepts. So what are the fundamental concepts in data analytics? So we will look at some key concepts which are coming to the picture, some types of data analytics, and some tools and techniques which we commonly use. So we are not diving too much into the technical background of all of these, but we will make sure that things are touched upon that give you enough information on what is coming up. Now, how to define the term? So we had a really simple definition in the beginning. Data analytics is all about making sense of your data. So at its core, so what happens in its entire process? So essentially what we do is we process the data to uncover patterns, trends, and insights. So these are the three critical terms in this definition. So we may identify some patterns, like, well, is there any particular way in which the data is behaving? We may identify trends. So what is the trend, or what is the forecast for this data? And insights, like why is a particular behavior happening that way? So all these can be extracted from data. And these three can essentially help us perform informed decision making. So instead of just taking a random decision, leverage this particular process to understand why something is happening, how something is happening, and what to do to take care of it. And this is done not in a single stretch. This is not recommended in a single stretch. Instead, we have a 4-level process which transforms your raw data into something that can be used. So the first step in that, so we call it the DIKW pyramid. And the first entry in that is data, which is the largest one. So that will form the base of the pyramid, which contains a huge pool of raw values. It may be some numbers, it may be some text, it may be anything. It could be some signal, it could be some files, anything that can be used. Forms the data layer, which is the base of the pyramid. Just on top, so pyramid, it's wider in the base and sharp in the top. So just on top of the data layer, we have something called as the information layer. So what happens there is your raw data is processed, condensed, analyzed, sometimes context is added, and essentially you compress it down to usable information. So that's one level of processing on top of this. So information is slightly more usable compared to data. So information, again, that itself is vast. So what we do, we have an additional layer on top called the knowledge layer, which is analyzed information, adding sense to what is being given in the information. So that is knowledge. And finally, wisdom, knowledge that can be applied. That is wisdom. And these terms may sometimes confuse people. So we have a simple example for the DIKW hierarchy, which is that of the humble tomato. So data is knowing that tomato is a plant. So it's a simple fact, nothing complicated. This tomato is a plant, very good. So that's data for us. Information. So now we have a plant. And when we say it's a plant, that comes with a lot of descriptions. So what kind of plant is it? What is the relation between tomato and that plant? Then what plant family does it fall under? So there's a lot of data coming along with that. And information means from that data, what we are extracting is the plant is Solanum lycopersicum. That's directly achievable from the data. And the relation between the plant and the tomato is it's the edible berry. So it's a berry. And the additional piece of information is it's a fruit. So how do we get that information? How we do that is the set of vegetables and set of fruits, the set of berries, they are all available as part of your whole data bank. It's a huge volume of data. From that, we can do different types of analyses, different types of comparisons, and understand that tomato is a fruit. That's information. So sometimes, if you just look at it, information may not make sense, but information is information. Knowledge. So we got some things as part of our information level. And knowledge means you shouldn't put tomato in a fruit salad. Just because tomato is a fruit, it doesn't always fit in a fruit salad. Does it harm anyone if you put it in fruit salad? May not. But does it make sense? Most of the time, no. Because conventionally, fruit salad does not contain a tomato. So that's knowledge for us. And wisdom takes that knowledge one step further. So if tomato is not put in a fruit salad, then something else should also come into the picture. And wisdom means tomatoes make great ketchup. So you grind tomatoes, process it to get ketchup. And that ketchup is not the same as a smoothie. So when you process the fruits in the same way, you get a smoothie. And tomatoes give ketchup. But even if tomato is a fruit, a ketchup and smoothie are not the same. So if you look at this hierarchy, This wisdom is achieved because the knowledge we obtained was, even if tomato is a fruit, it is not fit for a fruit salad. And how do you get that information? Tomato is still a fruit, but it doesn't share certain traits of fruits. And where do you get that information from? From the entire data bank of all fruits, vegetables, berries, or any edible items. So essentially, we are distilling the data into some usable insights. And one insight I can gain from this is, or my something that adds to my wisdom is, if I am opening a smoothie shop, I should not advertise tomato ketchup as a smoothie. That's the wisdom I get from this. So how does this happen in the real world? So as mentioned earlier, data sources are the largest layer in this entire pyramid, the data. And you source it from internal and external sources with stable data pipelines. So data pipeline means you get a consistent flow of data from a source to your whatever processing unit you are designing. And once you get a lot of data from sources, you do some processes called data warehousing and aggregation. And what it essentially does is build a solid platform to store this data. So data sources may give data at different speeds, different types. So there are variations. So a data warehouse essentially helps us structure this data into some usable format and make sure this data is of good quality, because data warehousing and aggregation involves things like error checking, then analyzing for empty data, analyzing for unusable data. All these processes take part as part of data warehousing and aggregation. Then once that is done, you have some usable data with you and you can explore the data, extract insights. So that may give you some information. Machine learning and data science comes into the picture afterwards. Extract the organized information, gain your knowledge, and finally applying that knowledge for business decisions, which is a manual process most of the time. So the automation normally stops at layer 4 because that is the best it can do. A machine cannot take a decision for you. It can only recommend you a decision. So level 5 is normally done by humans. And the key processes behind a typical data analytics task is collecting the data. So we are just linearizing the pyramid we saw earlier. So we collect data from different sources, then clean the data wherein we remove the errors, duplicates, inconsistencies. Then sometimes there may be cases where a part of the data has reached, but the rest hasn't. So we need to handle that as well. So once the data is clean enough, we can perform statistical data analysis, data mining. So we use statistics, mathematical techniques, understand patterns. So we may just take averages, we may plot graphs. There are umpteen techniques for that. Then visualization. So whatever you do, we normally go for visualization so that we understand why that happened. Sometimes it's easier to understand patterns from a graph than mathematics. And that's a fact which we have to accept. Mathematics gives you numbers. Graphs give you a visual. A picture is worth 1,000 words many times. And once you have visual and some statistics to support it, you end up taking decisions based on that. So this is the formal process. So you start with understanding the business, understand the data, prepare the data, model it, then evaluate whether it's good. If it is not, go back, understand the business again, so that cycle keeps going. And finally, once you see that it's good, then deploy it. Okay, so that's the process. So that was the basics of data analytics. So what are the different types of data analytics which we normally do? We start with descriptive analytics, which is just summarizing. So just know what happened. So we may say things like over the past 1 year, 30% of people switched from diesel or petrol to electric vehicles. So that's summarizing historical data. Then we have diagnostic analysis. So why did that particular thing happen? So in order to do that, we may be doing things like analyzing the circumstances that led to this. And we will end up seeing something like the cost of petrol and diesel increased. And at some point, electricity became cheaper. So people started switching, 30% of people switched. Then predictive analytics. So using this historical data, forecast future outcomes. Now, how do you do that? So we may say that at this rate, if the fuel price keeps increasing like this and the electricity prices keep increasing like this, at the end of the next 5 years, we will have 40% more people switching to electric vehicles. That's predictive analytics. And prescriptive analytics, based on the predictions, can you give recommendations for action? So we will say that increase the charging infrastructure because we are going to see more people switching to electric. So these are the different levels in which data analytics is done. And we have a number of algorithms that do this process, starting with linear regression, logistic regression, clustering, trees, neighbors, PCA, random forest, time series analysis, ANOVA, then some more advanced trainable models like neural networks, support vector machines, kernel machines, etc. It's just examples of all of this. Logistic regression, commonly used when we see that if you plot your data on an XY axis, there is some linear relation, everything focusing on a particular line. You can use linear regression really quickly. So that is where I said sometimes a picture is worth 1,000 words, because just by plotting it on a graph, you are able to identify that there is a linear relationship. Similarly, logistic regression, we have things focused on either ends of the spectrum. It's a good candidate for logistic regression. Then clustering, we have a lot of data points here, and you just cluster them or group them based on certain parameters. You will end up getting 3 or 4 groups. That's clustering. Then decision trees, random forest. Based on your data, you start making decisions. So in the first one, for example, if the age is less than 18 and weight is less than 60 kilos, it's a low-risk patient for heart diseases. If the age is less than 18 and weight is greater than 60 kilos, it's a high-risk patient. An age between 18 to 30 is low risk. Similarly, age greater than 30, if it's a smoker, it's high risk, otherwise low risk. So this is entirely based on the kind of data we get. May or may not be same in reality, but this is based on the data. And if there's a random forest, we will have multiple such trees and we vote the best decision out of them. Then if we have huge volumes of data, we can do principal component analysis, PCA, which shrinks it down to 2 or 3 values or 2 or 3 columns. Then we have time series analysis like ARIMA, autoregressive incremental moving average. Then ANOVA, to identify whether one set of values fit into the same group as another set. So these are all mathematical models in nature. And if you want more algorithmic and mathematical models, we have things like neural networks, which have multiple layers of things called neurons, which perform as simple as a weighted sum of the inputs to identify patterns among them. And you have things like kernel machines, support vector machines, all that. So all of these are potentially trying to identify certain patterns from the data. So these are all algorithmic or statistical in nature, but thankfully, not all the time do we need to implement all these from scratch, because there are a lot of tools which can do this. So this is something we call as a medallion model of data analytics. So we have a lot of data sources, PostgreSQL, Strata, DynamoDB, Kaggle datasets, MySQL, structured data in MySQL, unstructured in MongoDB. So in the bronze layer, we can do one level of analysis, wherein we have tools like Informatica, Pentaho, Airflow, Glue, all these to make sense of data in the first level. So they can crunch that data and kind of shape it up into something which we can use later. And that's done in the silver layer, wherein we have a much more heavy duty processing using things like Hadoop or Spark. Much more parallel processing is available there. And once we have done that level of analysis, we can extract even more insight and squeeze it out using the gold layer, wherein we use much more heavy duty AI models like Gemini or OpenAI or open models available in Hugging Face and libraries like Spacey and all. And once we have extracted all this, what do we do with that? The first thing we need to visualize, and that you can use tools like Grafana or Power BI, Tableau, QuickSight. All these are visualization tools. You may generate graphs, you may generate summaries, anything you wish, depending on your requirement. And based on the visual and the statistics, you can take the decisions. And since we are going to talk more on AI, this is where AI plays a part. We have the traditional AI models like TensorFlow or Flare or Spacey, PyTorch, all these things coming to the picture. And nowadays we have generative AI into this. So we have LangChain agents, Hugging Face models, OpenAI directly coming in, Amazon Bedrock, which hosts an array of models. So all these are available. And if you scale up the data to one more level, you have the big data models, wherein we have much more large scale processes, like we have batched and scheduled ingestions. So the entire data may not come in together. We will ingest it as smaller pieces, make sense of them, then move it to the next level, and then take the next piece. So we may have to do these processes in small batches and then consolidate at a later stage. So all these are possible when we have big data. And if we look at the medallion model, the silver layer is really commonly used for this kind of big data processing. Silver and gold, obviously the gold layer as also. But the advantage of using the silver layer applications are Hadoop, Spark, all these are really built for these kind of parallel processings. And Snowflake, they are all really good in storing data and managing data in parallel. So big data you can use really well. And one use case where these kind of processes happen. So Uber is something which we all use. So Uber uses a similar mechanism wherein we have a lot of data producers. All of these are fed to a pipeline, a real-time pipeline called Kafka. And from Kafka, we have this entire thing split into different destinations. Some things are notifications for your applications. They go to a PubSub, a publish subscribe model. Then we have real-time analytics, which is done by Flink. And then debugging, which is normally done by the ELK stack, the Elasticsearch, Logstash, Kibana stack. So which is having a dashboard-based system. And if you have really huge volumes of data to be processed, you send it to a batch pipeline built on Hadoop, which will help us explore insights. So the real-time pipeline is more focused on delivering service to the user, while the batch pipeline is more focused on delivering value to the application. So that's a typical use case. So that's about about data analytics. Now let's move to generative AI. So understand what it is about and what are the use cases. So generative AI, as the name indicates, is used to generate content, simple terms. And how do you generate content from that? You generate it based on patterns from existing data. So that's what it does. We started off with the Google releasing something called as the transformer model. So before that itself, the concept was there. Yeah, you had GANs and many other things, but suddenly this term came into popularity when you had Google releasing the transformers. Then we had GPTs, then the Codex, the Titans, then Lambda, all these, what can we say, giants, the internet giants publishing their own machine learning models. And these all fall under the particular class called the large language models, because these are heavily based on how we converse with each other by setting contexts, by setting your inputs in such a way that it's spread across a few words or a few sentences to generate the context. And these work similar to how we understand languages. So that is why they are called large language models. And they are called large because they accept a huge input volume. You can actually feed a paragraph or a page or even multiple pages into these and make sense of what is underneath. And these concepts rely heavily on things like a rule-based reward, which is very popularly used for ethical purposes nowadays, and the reinforcement learning with human feedback, because the humans are the best judges to judge the quality of your generative AI models. And if you look at where we use Gen AI nowadays, it's spread across the industry, used for things like image generation, text generation, content generation, personalization. So why it is so versatile is it is mimicking existing data patterns. It's not exactly tailored for anything. It's about mimicking the patterns. The only tailoring is for the type of data it is able to process, not the volume of data or the patterns it identifies. And nowadays, it's on the way to beat the Turing test. Turing test means you are sitting on a computer, somebody is talking to you, you need to identify whether it's a person or a chatbot. And nowadays, it's ready to beat the Turing test. Work is in progress on that. And we have seen applications like we have writing assistants, wherein you give a particular requirement, it will start writing your what can we say, stories, it will write poems, it will write programs if you need, it will write you anything. The content and idea creator, wherein you have a large, what can we say, a simple example, you want to create some marketing material, you ask it, I have this product, how can I market it? It will start generating the content for that. A generative and search assistant, which is now commonly used when you do a Google search, that's the one thing that pops on top, generated by Gemini. Then extract data, conversational search, the coding assistant, extension utility. So this is there all around us. Based on the industry, the exact application may change a bit, but it's not going to be radically different. And how this Gen AI transforms data analytics is, it will help us improve our data. It may help us generate synthetic data. It may help us expand our data. It will help us predict things. And sometimes it may explore previously unknown insights from data. And this is the difference we are seeing nowadays. Earlier, each kind of task had its own model or AI model. Now we are looking at something called as a foundational model, from which we are adapting it to its particular use case. So the same model may be able to cater to different things, and the only differences is in the type of data it is handling. The process remains the same. So that is why Gen AI is gaining so much traction now. You are not building 10 things for 10 purposes. You are building one thing, adapting it for 10 different purposes. This is nearly 6 months old. Now, if you look at it, I will have enough content to fill 6 pages with this. So as typical LM AI API stack, you have hundreds of providers nowadays who can give LLM APIs and adaptations. So this concept is on the rage now. So we quickly looked at what we do in data analytics, what Gen AI does. Now, where do these intersect? So if you look at Gen AI for data analytics, it is expected to complement traditional methods. So it is not going to be a replacement. It is not going to kill anyone's job, but it is going to be supporting the process. Then it can generate synthetic data. So for example, I may not have enough data to train my model, so it may be able to generate synthetic data. We will see it after this. Then it may suggest me some alternative data representations. So should I store this as CSV? Should I store this as an unstructured document? Should I store it as a JSON? Sometimes it may be able to recommend that. And you may be able to explore previously unknown insights. And if you look at it really high level, data analytics can help with data pre-processing, quality management, feature engineering, model evaluation, performance monitoring, tuning, reliability of models, user behavior analysis. So GenAI does all the heavy lifting, and data analytics can help improve GenAI with all this. It will help clean, or what can we say, improve the data given to GenAI. It will help keep track of how GenAI models are performing, and it will also help us understand how users interact with it. What kind of queries run into this? What is it commonly used for? All these. GenAI does a lot of data analytics support by complementing the analytics methods, data synthesis, explore other representations, and unknown insights. Some simple use cases: the use of GANs, means generative adversarial networks, to create synthetic data, autoencoders for compression, LangChain for analytics. So just a typical example. So here we are just asking a question. And what it does is, it understands that in order to answer the question, I need the help of many people. And what does it do? It will first create what we call as a set of agents. So these agents are going to explore how to solve this particular problem. And so it is going to look at the voters list. And for the voters list, the agent understands that it needs a database connection. So the database query is created, and the query returns some values. And then I need to visualize it. So essentially what it says is, James occurred how many times? 268 times. Mary occurred 221 times. Robert 215 times. So essentially, more than this exact example, it's about how GenAI agents, GenAI models can do this job. So my simple natural language query was converted into a sequence of steps with agents being assigned for each step. The agent's tasks being created by the model, executed by the model, returned, consolidated, visualized. So essentially, this entire task has been taken up and completed. Then we can do things like prompt chaining. So you have a person, you say, write a mission statement to suit this person. It will give you a mission statement. Find the key skills that support the mission statement. So essentially, this mission statement is the output or the response from the previous prompt. So that context remains in that GenAI system, and it will start responding with some skills and use the skills to write a resume. So then it generates a resume based on the mission statement and the skills. So you can chain multiple prompts one after the other, and you can use concepts like retrieval augmented generation, RAG, to support your response and the queries with your custom data, wherein the regular model will help, will take the help from your own data to do its job. So that's also done. So let's really quickly look at this intersection in a bit more detail. So I'm not going to take too much time because these are really simple applications. So one particular example, suppose we are building a model for healthcare data. Healthcare data is one of the most regulated in the world. One reason is people like you and me, we have our own privacy concerns. There are regulations that govern all this, like HIPAA. So we may not always be able to use that data directly for our models training. So one reason is, if there is any misfired prompts, it could potentially leak out the information. that it was trained upon. So if we have a reference data set, we can use a GenAI model. So now we call it GenAI model. Earlier, the reference we are taking is Generative Adversarial Network, GAN. It can generate fresh data sets that maintain the same statistical distributions. So basically, instead of training the model on the original data, I train it on the synthetic data. So even if there is a leak, nothing is going to happen. So that's data augmentation and synthesis. Another help that GenAI can do is it can translate between formats. Suppose I have a huge JSON file and need to convert it to CSV, you can use specific GenAI models for that, and vice versa. Then you may be able to do some data transformation. You may be able to summarize text before processing further. You may be able to clean some data, find which entries are missing, which have to be removed, which have to be which are duplicated and to be removed, all these. And you can even write a particular requirement in your natural language and convert it to programs using today's GenAI systems. So your requirement is, this is a typical example wherein your requirement is in plain text. It generated the entire program behind it. So that's a simple example. Then it can do predictive modeling. So essentially all these are neural networks in the background. So it can identify hidden patterns, simulate customer behavior. So that's really important. It will say that assume that you are an angry customer. Talk to me like how an angry customer would behave. And it will start generating these kind of conversations that simulate how this guy is expected to behave. So these things can be done. Then predict diverse scenarios. So you can tell it to assume scenarios and see how it is handled. Then again, stress test it like that. And again, you can do data imputation, wherein if there is any value missing, you can fill it with realistic values. You can use things like variational autoencoders for this. So normally when we do analytics, we have default options like you can fill an empty value with 0 or use the average, but instead you can use more realistic values. And even anomaly detection can be done. So you can train that model on a particular pattern. And if the current input doesn't seem to fit that, you can raise alarms. And as you retrain it, it will adapt to changes. So GenAI helps data analytics a lot. Now, how does analytics help GenAI? We have seen it already once, but we will just quickly go through it once again. So the biggest requirement for GenAI is data. So there are certain situations where data is slightly skewed. So in that case, data analytics may be helping with ensuring data distribution, clean the data. Then if there are too many columns or too much data which you may not need, a data analytics platform will help us select the features and transform them. Then you can split the data as required. Then when you select the model, you can analyze the data characteristics and select your model. For example, if it's an image generation, you can use GANs or now stable diffusion. For text generation, we have variational autoencoders, transformers, all these can be understood as a result of data analytics. Performance evaluation of models can be consistently done with data analytics. See how well the outputs are coming. Then optimization. So in case you feel that the model is not working properly for one category, you can synthesize data for that category and retrain. So that missing component is identified by data analytics. Where is it underperforming? So all these can be done. So what are the challenges and opportunities for this collaboration to happen? So when you consider challenges, the biggest concern is the ethical considerations, wherein your data has to be kept private. Make sure your data doesn't leak out. The model should be fair enough. So it should not be discriminative against ethnicity or color or race or anything. So that is to be ensured. And if there are regulatory compliances to be ensured, that has to be taken into consideration for the model, because there are certain geographical regions that impose loss on these AI models. But withstanding all these, if we can still improve AI or Gen AI to be more specific, we are looking at much better future opportunities wherein we have things like explainable AI. Your Gen AI model will be able to explain why it generated that output. Even now it's doing it, but it can do it better. Then federated learning, wherein this model is not trained in a single place, but split across regions, trained with local data and then consolidated together. So all these can be done. And now, even now, some of these are in progress, but we can do much more. And the best practices for a data analytics operation in today's era. Make sure you have clear objectives of what you're looking for. Make sure your data collection is proper. So there should be proper distribution, no bias. Choose your tool properly. What kind of model, what kind of prompts we are using? Is it working with any other tools? Evaluation and feedback. Make sure the outputs are proper. So there should be a feedback mechanism. And this is done by 3 sets of people. Your data scientist, who takes the decisions on what is the current process, where can we improve it, what are the quality problems, how is the data like. The machine learning engineer, who decides the data representation, selecting the models, what strategy is good, and is there infrastructure available. And the domain expert, to validate all of these, saying whether we are looking in the right direction, whether we are generating the right type of output, are the actions more suitable. So all these 3 stakeholders have to work together to incorporate. So the mantra for success is, don't stop at one round. Make sure you iterate. So choose a model, train the model, just deploy a sandbox, a dummy, measure the performance. So it looks burnt, so not good enough. Optimize it further, redeploy it, again measure, again burnt. So again, keep improving it. At some point, you will see that, dude, this thing is done. Let's make a new one. So you again choose a new model, trained model, do the same thing again, keep improving it till you find something that is good, and then deploy to your reality and you get a solution. And at the end of the solution, somebody says, this is not what we were looking for. If that's the case, you are wrong to begin with. Hire a better domain expert. They will be able to save the show. And if we look at some real world examples, we have examples in healthcare, manufacturing, agriculture, cybersecurity, finance, education, marketing, software development. Umpteen examples, but just giving some highlights. For healthcare, personalized medicine, drug discovery, chat-based interaction, cancer detection, predictive maintenance, design optimization in manufacturing, crop advisors for agriculture, cybersecurity, threat detection, fraud detection for finance, then vocabulary learning practices for education, campaign content creation for marketing, code generation for software development. So these are all cases where AI and data analytics have worked together a lot. And the common challenges are data quality, data quantity. Biggest challenge, your model is only as good as the data. Then the complexity of the model, how much time it takes to train the model, is there bias? Is the model generalizable? Is it too customized for my requirement? If so, it has to be general, a bit more general. Is the model interpretable? Is there any explanation coming out of this, or is it a black box? Such things are not really good. But regardless of what happens here, there are real good examples where these Gen AI and data analytics have improved the decision-making process, enhance the productivity, especially in case of things like software development, and increase competitiveness of people because they have better access to better tools. So not taking too much time further, so we we are coming to the end of this webinar. So we started off with the fundamentals of data analytics and GenAI, looked at how they work, why they are important, how they are important, where they intersect, what are the challenges and opportunities we have, why is data critical to this, why is an infrastructure critical to this, and how can we make sure it is successful. So make sure you iterate, make sure you don't stop at any mediocrity. And looking ahead, we have a really bright future, more models coming to the picture, multi-model AI, mixture of experts, a better stable diffusion for image generation, multimedia generation coming to the picture. Every industry is embracing this technology and trying to make their life better. Commitment to ethics, legal regulations are coming, intellectual property. So that is one thing which people want to look at. There were cases where intellectual property violations were reported, but handling that is important. Dangerous use of data. So how do we make sure that the data doesn't get used for unethical purposes? So that is something which people are looking at. And how to protect your data and taking ownership of decisions. AI cannot be taken to court because of its decisions. It's the ruling from many countries. So you yourself are responsible for implementing the decisions. AI only recommends that. So let's embrace the change. So things are changing. Continuous learning is important because you get more opportunities, better things to work with. Let's experiment a lot, iterate on the experiments, let's keep changing that, let's innovate and drive the change. So we should be the first people to drive change. Then using that, unlock opportunities, grow and advance. So before we stop, just a quick question to all of you is, I'm not expecting the response now, just think about it. Is there any pattern which you look at this, which you identify looking at this particular graph? And if you find something, you can drop it on the chat after this presentation. So thank you very much. Thank you very much for your patient listening. And the 5 Gen AI use cases, I leave you with this small note. Build more efficient workflows, automate the engineering and data process, democratize data, scale the customer support, and support translation language services, which is ubiquitous to any organization in any sector. With this, I conclude my words. Thank you very much for your patient listening. Have a great day.